Alright, so while you guys are getting set up here, we're going to be talking about graphs. And as we mentioned before, the whole point of talking about graphs is to visually represent the relationship between two variables as they both change. Okay, so we're going to represent data between two variables as they both change. And what we want to be able to do in this section for 4.1 is we want to be able to look at a graph, and we want to be able to talk about the variables of that graph, and we want to be able to describe that graph using words. Okay, we're going to describe that graph using words. So the first graph that we're going to talk about today together is air in a balloon. Have you ever blown up a balloon before? Yeah, like a water balloon, or making a balloon puppet or something like that. So what we're going to do is we're going to talk about air in a balloon, and this is our first graph that we're going to talk about. Okay, so I'm going to put time down here, and then I'm going to put volume over here. Okay, so what are the two variables that I am comparing here? Time and volume. So our variables are here. Our variables are time and volume. That's pretty straightforward. Okay, we're comparing time and volume, all right? And here's the graph. This is how it's going to go, all right? So it's going to go like this, and then like that, and 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 then it's going to drop off like that. Okay, so here we go. I have this picture. I have this graph of time and volume. So I am comparing the amount of air in the balloon, which is what we're calling volume, over time. Alright, so take a look at this graph here and come up with a description as to what you think is going on and what happens. Talk about it in your groups first before you talk about it out loud. Anybody want to tell us what they think could be happening here? Evan, what do you think could be happening going on with this picture?
So the person blows the balloon up and then takes a breath, blows the balloon up some more, takes a breath, and then blows it up some more and takes a breath, and then the balloon falls.
Okay, so you're saying that the person blows up the balloon and then right here takes a breath, then blows up the balloon, right here takes a breath, then blows up the balloon, and then right here what happened? You think the whole thing explodes or it pops? Okay, is there any other, that's a pretty good story, and that's generally what people come up with. Is there any other kind of story that could be happening here? Yeah, apply.
Well, what they said up until like the drop.
Yeah.
He could have just released the air.
He would have just let the balloon go, right? And then all of a sudden the air escapes the balloon really quickly, and then no air gets in there. Okay, what do you think?
If you
Well,
let the balloon go, then wouldn't it because the balloon doesn't go like down, it's going to have like another.
so he's saying that if we just let the air in the balloon, it'd be more kind of like that. It would take longer for it to deflate. Do you think it would take longer for the air to come out of the balloon if we just like let the balloon go, or if we just popped it? Which one would take longer? Let the balloon go. Okay, I tend to agree, right? So the actual story for this one is yes. So the description would be the volume increases each time we blow air until it pops. So we say, and noticing the volume increases each time we blow air until it pops. Okay, so notice that we are using both of the variables in the description, right? It would say the volume increases each time that we blow in the air until it pops. Okay, so over time, every time that we blow in air, the volume increases until it pops. All right, one thing that we want to make sure that we are able that we're doing here is noticing we're using this word increases. How do I know that this increases? It's pretty straightforward. How do I know? Wait, it goes up, right? The graph, basically, the graph is generally going up from left to right. That's called increasing. What would it be if it was decreasing? It'd be going down from left to right. So we read graphs the same way that we read books, left to right. Okay, so if we're as time goes on, then the volume is going up, it's increasing. So notice that in our description, we're using both the variables to describe it, and we're talking about a direction or a trend that's happening with the graph, okay? Okay, this graph is going to be, the title of this graph is length of a board, all right? So what are my two variables that I'm dealing with in this particular case? Length and time. Again, same thing, right? Time and length. Time and length. Okay, so Am I walking down a set of stairs here? No, I'm not walking. It looks like stairs, but I'm not walking down a set of stairs. Okay, that's the most common mistake. Most people think, oh well, we must be going down a set of stairs. No, not going down a set of stairs. Okay, so what could be going on here? Now, when I say a board, I'm talking about like a piece of wood, like a board wood. So what could be going on here? Yeah, what do you think?
The board is getting cut at a certain time. The chunk is getting cut off,
Mm-hmm.
and it's that length for a little amount of time, and then cut it off more.
So you're saying that this piece of wood is just getting cut at certain times. Is that right? Okay. So how many times does this board get cut?
3.
Yeah, 3 times. So right here, so up until this moment in time, the length of my board is whatever that is. I'll call it A, right? Then it gets cut at that moment in time. Then it goes down to B for that length of time. Then it gets cut here. And then it goes down to say C for that length of time. So it gets cut there, it gets cut there, and it gets cut there until finally the length of my board is whatever this value is down here over D. I'll call it D for what that is. So yeah. This is just describing that at certain times the length of the board gets cut. So it's important to know. We could ask all kinds of questions like how many times is it cut? Like how long before in between the first and the second cut was gone? Like how much time has been spent there? So how would you just describe this to somebody? What would you say? Just say it in words. Yeah, go ahead, Jay. What do you think?
The guy was cutting up the board, and then he cut, and then like took a little break, cut some more, took a little break, cut some more.
Okay, all right. So we could offer this. So we could say the length of the board remains constant until another piece is cut off. So the length of the board remains constant. Now, let's talk about that for a moment. Let's just talk about that part. Remains constant. How do we know that the length remains constant? What in the graph gives away the fact that the length remains constant? Plav, what do you think? The flat lines. So right here, right? That is a constant length of the board. This is a constant length. This is a constant length. That is a constant length. So the length of the board remains constant until what time? Until when? Until someone cuts it again, right? Until someone cuts the board. Okay, so, all right, a table is another way that we could use, that we could represent the way that two variables are changing relative to each other. So we've talked about graphs, now we can talk about tables. And of course, you can build a graph from a table, so it's important to talk about both of these at the same time, right? And that's what we're going to do right now. So we're going to talk about total downloads of a movie and then the days. So after 1 day, the total number of downloads is 346. After 2 days, it's 1,011. After 3 days, it's 3,455. After 4 days, it's 10,426. Okay, so I have some information in a table, right? Now that I have this information in a table, I want to make a graph to visually show the relationship between days and total downloads. So, to make a graph, right, we're going to use a straight edge. So here's my straight edge. And it comes out a lot easier. And we'll do another one. Okay, and what are my two variables that I'm working with here?
Days, downloads.
Very good. I got days and I have downloads. I have days and I have downloads. Oops, that's a B. Okay, now we have to make sure that we scale this correctly, right? So how many days am I working with here?
4.
I'm working with 4 days, all right? So I gotta make sure that I scale this out correctly. So 1, 2, 3, and then 4. So here's 1, here's 2, here's 3, here's 4, and so on. All right. Now, what about downloads? What am I working with here? It's a pretty big range, right? It goes from 346 all the way up to 10,426 downloads. So, how do you want to break this up? Remember, we're creating our own graph here. So how do we want to do it? Yes, Will, what do you think?
We can do 1,000
1,000. You want to go? So you want to go by increments of 1,000. All right. All right. I'm with you. So this top one here should be 10,000.
Yeah.
Okay.
Well,
Right. And then we'll just go a little bit above that. So that each one. So 10,000, 9,000, 8,000, 7, 6, 5, 4, 3, 2, and then 1. Kind of like that. All right, fair enough. So we'll say these are downloads, and we want to make sure that we say that these are in thousands, okay, so that we know what we're talking about. All right, so after 1 day, where are we at? We're at 346. So that would be right about, where would that be? If these are in thousands here, where would 346 be? If these are in thousands, where would 346 be?
it'd be like below.
It'd be way below. It'd be like right about here, right? Maybe something like that. Okay. So notice that I could represent that as a point in the plane, right? That could be located as 1, 346. So that could be a point in the plane. All right. What about the second one? Day after day 2, where are we at?
After day 2, 1,000.
1,000, and just a little bit more than that. So I'll go right about there. Okay. How about day 3? Where are we at?
We're at 3.
Almost like 3,500. So kind of in between, right? Okay. Good. And how about day 4? Where are we at? Whoa, shoot, we're at 10,000, like way above that. Okay, good. All right, so now I have these individual points of data, right? I have individual points of data. Would it make sense for us to connect this particular graph? No? Why do you say no? Why do you say no? Why would it not make sense to connect this particular graph? Jay, what do you think?
Because it's such a
Big
big range of numbers.
range of numbers, okay. What are we actually comparing here, too?
A day to download.
Yeah, after number of days to downloads, right? So after 2 days that we know how many we have, right? Do we care about like after 2.5 days? No, not particularly, not in this particular case. So some graphs will be connected, others will be individual dots. They don't have to be connected depending on the situation that we're working with. Okay, now that I can see the graph here, right? Now that I can see the graph, and I can see that the height of this one versus the height of that one versus the height of that one versus the height of that one, what is interesting about this graph, or what can we say, or what kind of information can we pull from this graph? Give me something that's interesting about it. Yeah. It's not constant. I agree with that. It's definitely not constant. What else do we know? This is great. It's perfect. Yeah, Jay.
There's a rapid spike until day 3 to day 4.
Yeah, from day 3 to day 4, almost like that video went viral, right? Boom, it exploded. So we have way more downloads after the 4th day than we did after the 3rd day, right? And that's clear from the picture of the graph, right? Another point that the graphs can be used to quickly show information about data, right? How would you describe this data to somebody? What kind of words would you say?
Probably really like that video.
It's a really interesting video. Okay. So as the number of days increases,
The downloads increase.
the number of downloads increases rapidly, right? Okay. You could say that. You could say there's with a giant increase, or with a significant increase between days 3 and 4. Right? You could say something like that. That'd be perfect. Okay, so I'm going to tell you a little story, and then you're going to draw a graph to represent the picture, to represent the story. Okay, so it has something to do with model rockets. So, a model rocket is launched from the ground. It goes to a certain height. At a certain height, parachute opens, and the model rocket comes back down to the ground. So what two variables could you be comparing? I'll say the story again. So the model rocket is launched from the ground. It gets to a certain height. A parachute opens, and it comes back down to the ground. All right? I want everyone to come up with variables and draw a picture of that graph that represents the story. So model rocket is launched from the ground. It reaches a certain height. A parachute opens, and it comes back down to the ground. All right, which two variables did you choose? Daniel, which two variables did you choose, buddy? You choose height and time. Okay, where'd you put the time? On the bottom, you put time down here. And then what'd you do with height? Oh, on the left hand side. Okay, good. What does your picture look like?
It like goes up and like curves and slowly goes down.
Kind of like, does it look like exactly like that?
No, it like on the second part when it goes down, it goes like slower.
So it goes up like this, right? And then kind of goes like that.
Yeah.
Is that what you did? Okay, so describe for me what's going on in this graph. Like, what does this first part represent? Where do things change? Like, how could you describe that? Anybody? Like, what does this part over here represent? That part of the graph.
The rockets like
How
going.
high was going.
Okay, so that's rising quickly. Okay, so I'm with you on that part. So it rises up quickly. Okay, what happens at this part over here? What's going on there?
Parachute opens.
Is that when the parachute opens?
No, it's just at its peak.
Yeah, this is when it runs out of fuel. Yeah, it runs out of fuel, right? Or the peak of it. I like that. Okay, and then what happens right here?
Then the parachute took
That's when the parachute opens, right?
slow descent.
And then what's going on down here?
Slow descent.
A slow descent. Okay, you guys got it. All right, very, very good.